Last year you learned about the unit circle, and we did a unit circle review, what was it, a couple weeks ago? So we're going to expand your knowledge of the unit circle, which will give you the sine and cosine and the tangent of, what is it, 20 angles from 0 to 360, 15, 30. I've given you a reference sheet. On one side is a unit circle, and on the other side are all of the trig formulas you need to have memorized in 2 weeks. Just kidding. No. I don't memorize the formulas. I used to have quite a few of them memorized, but not anymore. You will always have this reference sheet to help you, because nobody in their right mind would memorize all those formulas. Some of them you'll get used to, but there are subtle differences, and anyway. So today we're just going to focus on the unit circle. So I have a copy up here on the smartboard. What if I wanted to find the sine of 30 degrees? How do I do that? I go to 30 degrees right here. Sine is the y value. It's the height of the wall. So sine of 30 is 1/2. Now, should you forget that, never fear, reference sheet is here. Like that? So if you look on the reference sheet, right here are all of the ratios. Notice cosecant, secant, and cotangent are on there. You're going to use those today. Before we just kind of mentioned them and then skipped over them. Today you will use them. And then next to it are the unit circle definitions. Sine of theta is the y value. Cosine of theta is the x value. Tangent of theta is the y over the x. And look at cosecant. It says 1 over y, which means take the fraction the unit circle gives you and flip it upside down. So if I asked for the cosecant of 30, which is, you're going to take 1/2 and flip it upside down and get 2 over 1, which is just 2. The long way to do it would be 1 over 1/2, and then you have to flip it upside down. 1 over 1 times 2 over 1 is just 2. That's a mess. So it says 1 over y. You can find it that way, but the easier way is just to flip the sign upside down. For secant, flip the secant upside down. Okay? So what would the secant of 150 degrees be? Well, I go to 150, which is right here. Secant is the reciprocal of the cosine, so it's the reciprocal of the x value. My x value is negative root 3 over 2. That is the cosine of 150. The secant of 150 is negative 2 over root 3. But you're not allowed to leave a square root in the denominator. Do you remember the trick? Times it by root 3 over root 3. And the top is just negative 2 root 3, and the bottom becomes root 9, and the square root of 9 is 3. So the secant of 150 is negative 2 root 3 over 3. And in general, if you have 1 over root 5, what is that going to become? Root 5 over 5. So it looks like there's a lot of work there, but if you know the pattern, it's simple. What about 6 over the square root of 7? 6 root 7 over 7. Easy enough, right? Okay. What about the tangent of negative 120? Well, here's one way you can do it. 120 goes to there. So negative 120 would be what positive angle? 240. And if you notice, those are vertical from each other. Every negative angle is vertical from its positive counterpart. So negative 150, you could go to 150 and go straight down. Negative 30, you could go to 30 and go straight down. 315, if you had negative 315, you could go all the way around to 315 and then go straight up. That will always work. So, tangent of negative 120. I'm down here. And tangents, which values do I use? Y over x, and that's on your reference sheet. So, negative root 3 over 2 divided by negative 1/2. How do we divide two fractions? Flip and times. So 2 over negative 1. Negatives cancel. The 2's cancel. Wow. So it's just root 3. So the tangent of negative 120 is just root 3. Does that make sense? Let's do some radian measures. How about the secant of pi over 3? Secant is the reciprocal of cosine. So here's pi over 3. Cosine is the x. So it's the reciprocal of 1/2, which is 2. Good. All right. Cosecant of negative 5 pi over 3. Well, here's 5 pi over 3. The negative version is going to be straight up from that. And cosecant is the reciprocal of sine, which is the y value. So it's 2 over root 3, but I know, Hannah, you're just faster than the rest of us. I was ignoring you on purpose. So 2 root 3 over 3 is the answer. Not too bad, right? Let's do some large angles. What about the cotangent of 960 degrees? I don't like 960. So I'm going to subtract 360 from it. 960 minus 360. I don't like 600. Minus 360 again. 240. Cotangents would be found using x over y. It's the reciprocal of tangent. So if I go to 240 and I do x over y, negative 1/2 divided by negative root 3 over 2. Flip in times. So this is negative 2 over root 3. Negatives cancel. 2's cancel. I'm left with 1 over root 3. Root 3 over 3. Good. Okay. What about how about the secant of negative 18 pi over 4? Well, I don't see an 18 over 4 on the chart. So what should I do? Add 2 pi. So in my calculator, I'm going to do negative 18 over 4, and I'm going to add 2. And where do I want to get this number? Positive and below which one? 1, 2, or 3? 2. We want to be between 0 and 2 pi. Now technically, if we're between 0 and negative 2 pi, it would still work. But if you're going to be changing the value, you might as well change it until it's positive. Save yourself some time. So I added a full circle, and I'm still 2 negative. So add another full circle, still 2 negative. Add another one. Oops. Well, whatever. Add 2. So 1.5. Now what do I do with that number? You can change it into a fraction, and I get 3 pi over 2. 3 pi over 2 is right here. Secant is the reciprocal of cosine, which is the x value. So I'm going to turn my 0 over 1 into a 1 over 0, which is infinity. Right. The inverse of 0 is infinity. That's weird. The multiplicative inverse of 0 is infinity. Now you want something to really blow your mind? Multiplication inverses always multiply to be 1, correct? So 1/2 times 2 is 1. 3/4 times 4 is 4/3 is 1. So what is 0 times infinity? 1. Right? Now, it depends on your infinity. There are different versions of infinity. They're all infinitely large, but not all infinities are created equal. Wait, scratch that. Let's do a Animal Farm. All infinities are created equal, but some infinities are more equal than others. You guys have never read Animal Farm, apparently. All animals are created equal, but some animals are more equal than others. Same is true with infinities. Yes. Especially if you're a student in my class. Or even worse, my TA. Okay. I think that about covers it. Do you want to see any more examples? Would you like me to put the answers up on the board? Sí. Sí, maestro. Inteligente. All right. This worksheet will be due tomorrow.